Section 1. The Cosmic Horizon, where light stops and mystery begins. As we peer deeper into space, we encounter a boundary unlike any physical wall or cliff. The cosmic horizon. This horizon is not a tangible edge, but rather the limit of what we can observe, determined by the finite speed of light and the age of the universe. Everything we see, every galaxy, every nebula, every distant quasar, sits within this sphere of visibility. Beyond it, the universe continues, but its light has not yet reached us, and may never reach us at all. Imagine standing on a beach at twilight, watching waves stretch into the distance. The horizon appears to mark the end of the sea. But if you could fly or sail far enough, the water continues endlessly beyond what your eyes can see. Similarly, the cosmic horizon marks not the end of space, but the limit of our perception, a threshold where the observable universe gives way to the truly unknown. The observable universe spans roughly 93 billion light-years in diameter, a staggering scale that defies human intuition. Every photon we detect has traveled for billions of years, carrying information about conditions long past. When we look at the Andromeda Galaxy, we see it as it existed over 2.5 million years ago. When we observe galaxies at the edge of our cosmic horizon, we witness them as they were nearly 13 billion years in the past. Beyond this horizon, light emitted today has yet to arrive, and for many regions it may never arrive due to the accelerated expansion of space. This accelerated expansion is one of the most profound discoveries of modern cosmology. Galaxies are not simply moving through space. Space itself is stretching, carrying galaxies away from us. For regions beyond a certain distance, the rate of expansion exceeds the speed of light, meaning their light can no longer reach Earth. In essence, parts of the universe are permanently receding from our view, rendering them invisible forever. The cosmic horizon, then, is a moving boundary shaped by both the finite speed of light and the dynamic stretching of space-time. The implications are extraordinary. Beyond the horizon lies a region of the universe that is unknowable in principle. We can speculate about its properties, guided by the uniformity observed within the observable universe, but direct observation is impossible. Cosmologists rely on assumptions called the cosmological principle, which suggests that the universe is roughly homogeneous and isotropic on large scales. If this principle holds, the unseen regions may resemble what we see. Yet the possibility remains that entirely different conditions exist, regions with exotic matter, unusual physical constants, or even entirely different cosmic structures. One fascinating aspect of the cosmic horizon is the relationship between space, time, and observation. Light from distant regions takes billions of years to reach us, so we are always looking into the past. The universe beyond the horizon may exist in forms vastly different from what it was when its light began its journey. Perhaps stars have already lived and died there, galaxies have merged and evolved, or entirely new cosmic phenomena have emerged. The horizon, therefore, is a window into both the farthest distance and the deepest history, a reminder of the temporal dimension woven into space itself. This boundary also encourages us to think about infinite space. While the observable universe is finite in extent, the unobservable universe could be infinite. If space is unbounded, then beyond the cosmic horizon lies an endless expanse of galaxies, stars, and perhaps life itself. Infinity challenges our imagination, stretching the mind in directions that defy human experience. We are creatures accustomed to edges and limits, yet the universe whispers of regions that may never end, inviting contemplation without closure. Mathematical models suggest that even beyond the cosmic horizon, familiar physics may not apply universally. While the laws of gravity, electromagnetism, and quantum mechanics govern what we observe, regions we cannot see could feature alternative physical constants, fundamentally different arrangements of matter or energy landscapes unimaginable to us. In this sense, the horizon is not just a limit of sight, but a gateway to conceptual exploration, encouraging speculation about what is possible in realms beyond observation. The cosmic horizon also has philosophical resonance. It is humbling to recognize that our knowledge of the universe is intrinsically limited, that for every discovery there exists an infinite expanse we cannot directly examine. Yet this limitation does not diminish the majesty of the cosmos. Instead, it enhances our appreciation, reminding us that curiosity and wonder are as important as comprehension. The edge of what we can see is not a wall to fear, but a threshold to ponder, a boundary that inspires both scientific inquiry and quiet reflection. Consider, too, the human experience of the horizon. Every telescope, every space probe, every measurement stretches our perception a little further. But no matter how powerful our instruments become, the cosmic horizon will always exist. It is defined not by technology, but by the fundamental nature of light, time, and space. Standing at this threshold, we confront a profound duality. The universe is simultaneously knowable and unknowable, vast and intimate, eternal and fleeting. In practical terms, studying the cosmic horizon guides our understanding of cosmology. Observations of the cosmic microwave background radiation, the afterglow of the Big Bang, allow scientists to infer conditions at the universe's earliest moments. By mapping subtle variations in this radiation, cosmologists construct models of large-scale structure, cosmic inflation, and dark energy. These studies reveal a universe that is dynamic, evolving, and full of hidden complexity, providing indirect glimpses of regions we can never directly see. And yet, despite the vast unknown, the horizon also offers comfort. It frames the universe in a context we can comprehend, a measurable expanse within which we can observe, theorize, and imagine. Beyond it lies mystery, yes, but also possibility, creativity, and wonder. Every thought about what exists beyond the cosmic horizon expands not only our scientific understanding, but also our imagination, allowing us to explore realms beyond sight without fear or constraint. The cosmic horizon is ultimately both a limit and an invitation. It marks the boundary of human observation, yet it beckons the mind to contemplate infinity, the unknown, and the unseeable. Beyond this horizon, the universe may stretch endlessly, harbor alternate realities, or reveal phenomena that challenge the laws we hold dear. It is a silent frontier, invisible yet present, and it reminds us that the universe is far larger and far more mysterious than any single mind or telescope can encompass. In the quiet of night, as we gaze upward at the stars, we can imagine this horizon stretching beyond comprehension, a reminder that curiosity is as infinite as the cosmos itself. The edge of what we can observe is not the end. It is a beginning, a space where science meets imagination, where wonder merges with contemplation, and where the universe whispers secrets that will forever invite us to listen. Section 2. The Multiverse. Many worlds beyond our sight. As we step beyond the cosmic horizon in imagination, one of the most compelling possibilities arises: the existence of a multiverse. This concept suggests that the universe we inhabit, vast and seemingly infinite as it is, might be just one of countless universes, each with its own laws of physics, histories, and forms of matter. In this vision, the edge of our universe is not a wall, but a window into an even larger reality, where countless other worlds may exist in parallel, hidden from our direct observation. The idea of a multiverse emerges naturally from modern cosmology, particularly from the theory of cosmic inflation. In the earliest moments after the Big Bang, the universe is thought to have expanded exponentially, doubling in size countless times in a fraction of a second. Inflation was not a uniform process. In some regions, it may have slowed, while in others, it continued, creating bubble universes separated by vast stretches of space-time. Each bubble could develop its own distinct properties, its own stars, galaxies, and physical constants. In this sense, our universe could be just one bubble floating in an infinite cosmic ocean. The multiverse concept challenges the very notion of boundaries. In such a framework, the edge of our universe is simply the limit of our observational horizon. Beyond it, other universes may exist, each inaccessible to our instruments, yet real in their own right. Some universes could be strikingly similar to ours, with the same particles, forces, and even life forms. Others might be almost unrecognizable, where gravity behaves differently, light travels at different speeds, or chemistry as we know it cannot exist. The multiverse is a symphony of possibilities, each universe a unique variation on the theme of existence. One particularly fascinating implication is the concept of parallel realities, where events unfold differently from our own. In some universes, galaxies may never have formed, leaving vast voids of empty space. In others, stars could burn with colors we cannot imagine, governed by alternate physical laws. Even fundamental aspects of time and space could vary, creating realities where cause and effect operate differently. These ideas invite quiet reflection, a gentle awe at the creativity of the cosmos. The multiverse also provides a framework for understanding the fine-tuning of our universe. Certain physical constants, such as the strength of gravity or the charge of the electron, seem precisely calibrated to allow the formation of stars, planets, and life. In a multiverse, this fine-tuning may be less mysterious. With countless universes, each with different parameters, it is not surprising that at least one, like ours, has the right conditions for life. This perspective is both scientifically elegant and philosophically comforting, suggesting that our universe is a natural product of cosmic diversity rather than an isolated miracle. Some theories even suggest that universes can interact, albeit in ways we may never directly detect. Quantum mechanics hints at entanglement and correlations that defy classical understanding, and in some speculative models, universes might bump against each other, leaving subtle imprints in the cosmic microwave background. These interactions, if they occur, would be almost imperceptible, yet profound, evidence that the multiverse is not just a collection of isolated bubbles, but a dynamic, interconnected ensemble of realities. Despite the grandeur of the multiverse idea, it is important to approach it with calm curiosity rather than fear. These concepts are not threats. They are contemplations of scale and possibility. They expand our understanding of existence, showing that life, matter, and even time may be far more varied than we can directly perceive. By imagining multiple universes, we cultivate a sense of humility and wonder, recognizing that our universe, as vast as it is, may be one chapter in an infinite cosmic story. There is also a meditative quality to considering the multiverse. It allows the mind to drift beyond the familiar, to contemplate infinity without urgency or pressure. Each hypothetical universe is like a room in a vast, unending mansion, and we, from our tiny corner, can only glimpse hints of what lies beyond. This gentle perspective encourages reflection. The universe is both known and unknowable, intimate and infinite, inviting us to marvel rather than to conquer. The multiverse also has profound philosophical resonance. It challenges the notion of uniqueness, suggesting that our experiences, choices, and even existence may have echoes in other realities. Yet rather than diminishing the significance of our lives, this idea can inspire a quiet gratitude. We are alive in a universe capable of supporting consciousness, capable of sustaining wonder, and capable of inspiring exploration. Even if countless other universes exist, each one, including ours, is a miraculous expression of cosmic possibility. Modern physics, particularly string theory, adds further layers to the multiverse hypothesis. String theory proposes that fundamental particles are not points, but tiny vibrating strings, and these vibrations can manifest in a multitude of ways. The result is a vast landscape of possible universes, each with its own geometry, forces, and dimensions. While these ideas remain theoretical, they suggest that the edge of our universe may be merely a gateway to an unimaginably vast landscape, a place where the familiar laws of nature are just one of many possible arrangements. Finally, considering the multiverse encourages a perspective of patience and acceptance. We may never directly observe these other universes, and yet contemplating them expands our minds, opening space for imagination and reflection. The cosmic horizon, once a boundary, transforms into a threshold of wonder, inviting us to explore not through travel or observation, but through curiosity, reason, and quiet contemplation. In the end, the multiverse transforms the edge of the universe from a limit into a portal of possibility. Beyond our observable sphere, there may be realms of unimaginable beauty, diversity, and complexity. Each universe is a testament to the creativity of existence, a gentle reminder that the cosmos is far larger, stranger, and more intricate than our minds can fully grasp. And as we imagine these realms, we participate in a timeless human tradition, gazing into the unknown and finding calm, awe, and inspiration in its infinite expanse. Section 3: Higher Dimensions and the Edge of Reality. As we continue our journey beyond the observable universe, one of the most mind-expanding ideas arises from higher dimensions. Beyond the 3 spatial dimensions and 1 time dimension that we perceive, physics suggests that additional dimensions may exist, hidden from our senses, yet shaping the very fabric of reality. These dimensions are not merely theoretical curiosities. They offer a profound way to contemplate what lies beyond the edge of the universe, where familiar notions of space and time may dissolve into entirely new geometries. The concept of higher dimensions arises naturally from string theory. According to this theory, the fundamental particles of nature are tiny vibrating strings, and the vibrations of these strings determine the particles' properties. Remarkably, for these strings to function mathematically, the universe must contain additional spatial dimensions beyond the 3 we experience. Some versions of string theory suggest as many as 10 or 11 dimensions, most of them compactified, curled up so tightly that they are imperceptible to human senses. These extra dimensions could extend infinitely beyond the observable universe, forming a landscape where reality unfolds in ways we cannot intuitively grasp. Imagine, for a moment, a 2-dimensional being living on a flat sheet of paper. To this being, only length and width exist. Height is incomprehensible. Yet a 3-dimensional object could pass through its plane, unseen from within its own perspective, leaving traces of its presence. Similarly, higher dimensions in our universe might interact with our familiar 4-dimensional space-time in subtle, almost imperceptible ways. The edge of the observable universe could intersect with these dimensions, hinting at realms that exist alongside our own, yet remain invisible, beyond the reach of conventional observation. Higher dimensions offer intriguing possibilities for the structure of the universe itself. Some cosmologists speculate that what we perceive as the cosmos may be a 3-dimensional brain floating in a higher dimensional space. Other brains could exist nearby, separated by dimensions we cannot perceive, and interactions between these brains might manifest as gravitational effects, or even give rise to new universes. In this view, the edge of the universe is not a boundary at all, but a threshold where multiple realities overlap, intersecting in subtle and mysterious ways. The idea of higher dimensions also opens the door to new interpretations of cosmic phenomena. Dark matter and dark energy, enigmatic substances that make up most of the universe, might be manifestations of matter and energy residing in higher dimensions. If so, The universe beyond our observable horizon could be shaped by interactions with these hidden dimensions, influencing the formation of galaxies, the expansion of space, and the overall evolution of cosmic structures. In this sense, the edge of the universe is not simply distant space. It is a frontier where unseen forces sculpt reality itself. Quantum mechanics adds further nuance to the idea of dimensions beyond perception. At extremely small scales, particles behave in ways that defy classical intuition, existing in superpositions, entangled across distances, and influenced by probabilities rather than certainty. Some interpretations suggest that these quantum effects might be hints of higher dimensional spaces where multiple outcomes coexist simultaneously, and the apparent randomness of the universe emerges from unseen structures. Beyond the edge of the observable universe, such quantum dimensions could unfold on vast scales, creating regions of reality fundamentally different from our own. The concept of higher dimensions is also deeply calming when approached contemplatively. It reminds us that the universe we perceive is only a fraction of the whole, and that reality may be far more intricate, subtle, and beautiful than our senses alone can detect. Standing at the edge of the observable universe, we can imagine invisible dimensions stretching infinitely, shaping our cosmos in ways that remain hidden yet profoundly influential. The unknown is no longer a void to fear, but a canvas for imagination and reflection, inviting us to explore not through sight, but through thought and wonder. Higher dimensions may even offer pathways to phenomena that in our three-dimensional experience seem impossible. Wormholes, time loops, and shortcuts across space could be understood as consequences of geometry in higher dimensional spaces. What appears as a vast, empty stretch beyond our cosmic horizon might actually contain structures, corridors, or connections shaped by unseen dimensions, hidden highways of reality, bridging regions otherwise separated by incomprehensible distances. This perspective also transforms our sense of scale. Beyond the familiar edge, distances may lose their usual meaning. Concepts like here and there, near and far, become fluid, governed not solely by the geometry of our observable space, but by the topology of higher dimensional realms. In such a universe, the edge is not a limit, but a threshold to new ways of understanding space, time, and connection. Ultimately, contemplating higher dimensions encourages both scientific curiosity and philosophical reflection. It teaches humility, showing that the cosmos may be far more elaborate than any single theory, experiment, or observation can capture. And it inspires awe, revealing that the universe, even beyond its observable limits, may be filled with structures, patterns, and possibilities beyond imagination. The edge of the universe is not a wall, but a gentle reminder that reality extends beyond perception, inviting us to explore the infinite in thought, wonder, and quiet contemplation. Beyond the cosmic horizon, beyond light and matter, and possibly beyond even time itself, the universe may unfold in dimensions we cannot perceive but can imagine. This calm realization offers perspective. We are part of a vast, multi-layered cosmos, a fraction of a grander reality. and our minds, curious and reflective, can touch its edges in contemplation. The universe is, in a sense, infinite not only in scale, but in depth, layers, and possibility. And so, as we reflect on higher dimensions, we are reminded of a profound truth. The edge of the observable universe is not a boundary to fear or despair, but a serene invitation to expand our understanding, to imagine possibilities beyond perception, and to recognize that reality is far more beautiful, intricate, and infinite than we can see. In this calm contemplation, we find both awe and comfort, a gentle sense that the universe, and all it may contain, is far larger and more wondrous than our minds can fully comprehend. Section 4. Quantum Realms and the Nature of Nothingness. As we move beyond the familiar expanse of stars and galaxies, we enter a realm where the very fabric of reality becomes subtle, delicate, and mysterious. The domain of quantum possibilities. Beyond the observable universe, the concept of nothingness is not empty in the classical sense. Instead, quantum physics reveals a seething, dynamic foundation where energy fluctuates spontaneously. Virtual particles flicker into existence and vanish, and the vacuum itself hums with potential. To contemplate what lies beyond the universe is, in part, to contemplate this quiet, invisible, and infinitely complex quantum realm. At the smallest scales, the universe behaves in ways that defy ordinary intuition. In quantum mechanics, particles are not solid objects, but probability waves, existing in multiple states until observed. Space itself, at the quantum level, is not smooth and continuous, but may be a turbulent foam, fluctuating with energy in patterns too small for the human eye to detect. Beyond the cosmic horizon, where light cannot reach, this quantum foam may extend endlessly, forming the hidden substrate from which universes emerge, evolve, and possibly collapse. Even what we call empty space is rarely empty. The vacuum is filled with virtual particles, momentary blips of energy that appear and vanish in less than a trillionth of a second. These fleeting entities have measurable effects, influencing the behavior of atoms, light, and fundamental forces. In the context of the universe beyond the observable horizon, such quantum activity may dominate regions where matter, stars, and galaxies are absent. Here, beyond our perception, nothing is truly nothing, and the silence of space hides an invisible dance of energy and potential. This understanding leads to the notion of vacuum energy and the cosmological constant, mysterious quantities that shape the expansion of the universe. The vacuum itself may exert a subtle pressure, driving space to expand ever faster. In regions beyond our sight, this energy could influence the growth of distant universes or even give birth to new ones. The edge of the universe, therefore, is not merely a physical horizon, but a threshold where the unseen quantum scaffolding of reality stretches into infinity. Quantum mechanics also allows for the possibility of quantum tunneling and spontaneous creation. In principle, entire universes could emerge from nothing due to the probabilistic nature of quantum events. This is not mystical speculation. It is a natural consequence of the mathematics of quantum fields. Beyond our observable universe, There may be regions where new cosmic domains spontaneously bubble into existence, expanding in dimensions and shapes unfamiliar to us. The cosmos, in this view, is alive with subtle energy, constantly giving rise to new realms beyond the horizon of perception. The concept of nothingness itself becomes philosophical. In classical thought, nothing is a void, a complete absence of matter and energy. Yet quantum theory teaches us that nothingness is pregnant with potential, a dynamic arena where reality is never static. Beyond the observable universe, this quantum nothingness may stretch endlessly, punctuated only by emergent universes, ripples of energy, and the occasional spontaneous formation of matter. The edge of the universe is, paradoxically, a space of infinite possibility disguised as emptiness. Another intriguing possibility arises from quantum entanglement. Particles can be correlated across vast distances, their states linked instantaneously in ways that defy classical physics. Beyond the cosmic horizon, entangled particles might connect regions otherwise beyond our reach, creating subtle correlations across the unseen expanses. The universe may be interconnected on scales far larger than our perception, with hidden patterns and harmonies extending into the regions we can never directly observe. In this sense, even beyond the horizon, the cosmos remains coherent, a vast network of possibilities waiting to be explored in thought. The quantum perspective also reshapes our understanding of time. Beyond the observable universe, the flow of events may be influenced by probabilistic fluctuations, regions where cause and effect take on unexpected forms. The future and the past may blur in ways that challenge conventional reasoning, and time itself may emerge from underlying quantum processes. The edge of the universe, in this view, is not simply a spatial boundary, it is a temporal frontier, a place where the familiar rules of chronology and causality may give way to deeper, subtler structures. Meditatively, contemplating the quantum realm beyond the universe is deeply calming. It invites the mind to rest in possibility rather than certainty, to accept that the cosmos is not merely a collection of stars and galaxies, but a living, dynamic tapestry of energy and potential. The vastness of the universe is mirrored by the infinitesimal activity of the quantum world, suggesting a profound unity between the grand and the subtle. Beyond the cosmic horizon, the mind can imagine a silent symphony of energy, vibrating in patterns we may never observe, yet shaping all that exists. The implications for our understanding of existence are profound. If regions beyond our observable universe are dominated by quantum fluctuations, then the cosmos is more than a physical expanse. It is a creative, generative process. Universes, matter, and even life could emerge spontaneously in distant realms, continuously expanding the scope of reality. The edge of the universe in this light becomes not a limit but an invitation, a quiet threshold where imagination and mathematics converge to suggest infinite possibilities. Finally, contemplating quantum realms beyond the universe encourages a serene humility. We are tiny observers, confined to a bubble of space-time and a fraction of the cosmic story. Yet even in this limitation, we can explore, reflect, and appreciate the subtle, elegant structures that govern existence. Beyond the edge, The universe stretches into infinity, not as a void to fear, but as a silent, beautiful ocean of potential, where the familiar laws of physics fade into possibilities unbounded, unseen, and endlessly wondrous. In the end, quantum realms and the nature of nothingness teach us that the universe is more than matter and light. It is a dynamic, creative expanse, stretching infinitely beyond the cosmic horizon, inviting contemplation, wonder, and quiet awe. The edge of the universe is not a wall, but a gateway into the subtle and beautiful mysteries of existence, where possibility dances in silence, and reality itself continues to unfold in ways that will forever inspire curiosity, reflection, and wonder. Section 5: Cosmic Inflation and the Ever-Expanding Frontier. Beyond the observable universe lies a realm shaped by forces so vast and subtle that human imagination strains to contain them. One of the most profound of these forces is cosmic inflation, a period of exponentially rapid expansion that occurred in the universe's first fleeting moments. This epoch, lasting less than a trillionth of a second, caused space itself to stretch faster than the speed of light, smoothing out irregularities and setting the stage for the cosmos we observe today. Yet cosmic inflation may not have been confined to our universe alone. Its effects could extend into regions forever beyond our observational horizon, shaping an ever-expanding frontier of unseen space. To grasp the scale of inflation, imagine blowing a tiny balloon with a pinhole inside. In an instant, the balloon expands enormously, stretching the pinhole and all markings across its surface. In the early universe, inflation stretched tiny quantum fluctuations into vast regions that later formed galaxies, clusters, and cosmic filaments. Beyond the observable universe, similar regions may exist, formed from the same processes yet forever out of reach. Each of these regions is a continuation of our universe's story, a testament to the immense power of inflationary forces. Cosmic inflation leads naturally to the concept of a multiverse of bubble universes. In this picture, different regions of space stop inflating at different times, creating discrete pockets or bubbles. Each bubble can evolve independently with its own physical laws, constants, and structures. Our observable universe is one such bubble, but beyond the edge, countless others may float in a vast, ever-expanding space-time. Some might resemble our universe closely, others may be radically different, with exotic matter, strange forces, or entirely unfamiliar physics. The edge of the observable universe is thus a threshold, beyond which new cosmic realms unfold in infinite variety. This continuous expansion also has a quiet philosophical resonance. The universe is not static. It is dynamic, evolving, and unbounded. What we perceive as empty space beyond the horizon may be filled with regions in the process of formation. Areas where galaxies are just beginning to coalesce or where physical laws differ in subtle ways. The cosmic frontier is alive with potential, a reminder that reality is not fixed, but continually emerging, and that the universe, even beyond our sight, is a landscape of possibility. Inflation also offers insight into the uniformity of our observable universe. Despite its immense size, the cosmos appears remarkably homogeneous and isotropic. Regions separated by billions of light years share similar temperatures, densities, and structures. Cosmic inflation explains this by stretching space so rapidly that tiny initial variations were smoothed out. Beyond our observable horizon, similar smoothing may have occurred, producing vast, silent expanses of space whose properties mirror our own, even if their light can never reach us. This suggests a continuity to the universe, a quiet symmetry extending into the unseen. Yet the frontier beyond inflation is not merely a repetition of familiar patterns. Quantum fluctuations during inflation concede regions with radically different outcomes. Some universes might expand into voids devoid of stars. Others may be dense with primordial black holes or strange exotic matter. Each fluctuation represents a branching possibility, a unique unfolding of cosmic potential. The edge of the universe, then, is not a barrier, but a canvas for infinite variation, a place where randomness and structure coexist in delicate balance. The expansion also highlights the profound interconnectedness of space and time. As the universe inflates, distances grow, and events that seem simultaneous from one perspective may unfold differently from another. Time itself is woven into this expansion, stretching along with space. Beyond the observable horizon, the flow of cosmic events may differ from what we perceive, creating regions where history diverges in subtle or dramatic ways. The edge of the universe becomes a temporal as well as spatial frontier, where conventional notions of past, present, and future blur. Despite its scientific complexity, contemplating the inflationary frontier can be deeply calming. It reminds us that the universe is vaster and more intricate than we can see. Yet there is order and elegance underlying even its most distant reaches. Beyond the horizon, space is not chaotic, but structured by the gentle principles of physics, shaped by forces both subtle and immense. The mind can wander across these unseen expanses, imagining galaxies forming, cosmic filaments stretching, and quantum fluctuations giving rise to new regions, all unfolding in quiet harmony. Cosmic inflation also encourages reflection on our place in the universe. Human existence occupies a minuscule fraction of space and time, yet we can contemplate regions beyond billions of light years and billions of years of evolution. The edge of the universe invites humility, showing that our perspective is limited, but it also inspires awe, for the universe's complexity, beauty, and creativity extend infinitely beyond perception. Each unseen region is a silent testament to the grandeur of cosmic forces, a reminder that the universe is simultaneously knowable and mysterious. Finally, cosmic inflation points to a universe that is never truly bounded. Even as we map galaxies and measure cosmic background radiation, we glimpse only a fraction of reality. Beyond the observable horizon lies an infinite expanse of space and possibility, shaped by the same processes that gave rise to stars, galaxies, and life, yet unobservable and ungraspable. The edge of the universe is not a wall, but a gentle invitation to contemplation, a threshold beyond which imagination, mathematics, and wonder converge. In the quiet of reflection, we can imagine this expanding frontier as a serene, boundless ocean. Galaxies float like distant islands. Quantum fluctuations ripple like gentle waves, and the fabric of space-time stretches quietly into infinity. Beyond our sight, new universes may bloom, forces may shape matter in unfamiliar ways, and the story of existence may continue endlessly. The edge of the universe is not a limit, but a horizon of infinite calm and possibility, reminding us that reality is far larger, richer, and more wondrous than any single observation can capture. Section 6: Exotic Universes and Alternate Laws of Physics. Beyond the edge of the observable universe lies a realm where the familiar laws of physics may not apply. While our universe follows well-established patterns of gravity, electromagnetism, and nuclear forces, there is no reason to assume that regions beyond our perception adhere to the same rules. In these distant, unobservable realms, exotic universes might exist, places where reality itself is crafted from entirely different foundations, and where the constants of nature that govern matter, energy, and time may take on unfamiliar values. Consider the fine-tuning of our universe. The strength of gravity, the charge of the electron, and the balance of nuclear forces are all precisely arranged to allow stars, planets, and life to emerge. Even a slight variation could prevent the formation of galaxies or the existence of atoms. Beyond the observable horizon, other universes may have different constants. Some may be too unstable for matter to coalesce, leaving vast expanses of empty space. Others might be dominated by forces that create stars far larger or smaller than our sun, or entirely unfamiliar forms of matter. In these regions, the cosmos could be both alien and breathtaking, a demonstration of nature's limitless creativity. The concept of alternate physical laws extends to dimensions beyond the familiar, 3 of space and 1 of time. Some exotic universes might contain extra spatial dimensions that are macroscopic, affecting the behavior of light, gravity, and motion in ways that defy our intuition. Others might have time that flows differently, either at a variable rate or even cyclically, producing realities where cause and effect operate in unexpected ways. These are not merely theoretical abstractions. They are mathematically plausible extensions of current physical theories, such as string theory and M-theory, which allow for countless ways in which a universe can exist. One particularly fascinating possibility is a universe dominated by dark energy or dark matter in extreme forms. In such regions, expansion could be vastly faster or slower, shaping galaxies and cosmic structures unlike anything in our own universe. Some universes may be filled with strange mirror matter, invisible to ordinary interactions, but influencing gravity and motion. Others might host entirely new forms of particles and forces, giving rise to phenomena unimaginable to human perception. The edge of our observable universe may be merely the threshold to a cosmic kaleidoscope of realities, each with its own internal logic and beauty. These exotic universes also invite contemplation of parallel outcomes. In some regions beyond our horizon, stars may have formed differently. Planetary systems may follow unfamiliar orbits, and chemistry itself might be altered. In such places, life, if it exists at all, would be fundamentally distinct from our own, adapting to physics and chemistry that challenge our understanding. Even consciousness, perception, and the passage of time might be unrecognizable. The universe beyond the edge, therefore, is not a continuation of what we know, but a vivid landscape of alternate possibilities. Philosophically, these ideas are both humbling and inspiring. They suggest that our universe, with its familiar stars, galaxies, and physical laws, is a single expression in a vast ensemble of cosmic diversity. Beyond the horizon, reality may not be constrained by the rules that define our experience. The universe we see is just one melody in an infinite symphony, and the unseen expanses beyond are filled with harmonies we can imagine but never fully hear. This perspective encourages quiet reflection. Our existence, though extraordinary, is part of a far larger, more intricate tapestry. The possibility of exotic universes also raises profound questions about causality and creation. If different regions of reality obey different laws, then the processes that form matter. Stars and galaxies could vary in ways that are unrecognizable to us. Inflation may create regions where universes spontaneously bubble into being with distinct properties. In these realms, the edge of the observable universe is not a boundary, but a seedbed of creative potential, where new domains continuously emerge, evolve, and transform according to alternate rules. Meditatively, imagining these regions beyond the edge of space is deeply calming. The cosmos is not limited to what we can perceive. It is infinitely diverse and generous, filled with possibilities that extend beyond comprehension. The unfamiliar physics of distant universes invites us to release the need for certainty, to embrace mystery, and to marvel at the quiet complexity of reality. Each exotic universe becomes a gentle reminder that existence is both orderly and endlessly creative, that infinity is not threatening, but awe-inspiring, and that the cosmos is far larger than the mind can fully grasp. There is also a subtle beauty in the notion of universes with alternate laws. Even if they are forever inaccessible to us, contemplating them expands our understanding of what is possible. Beyond our cosmic horizon, the rules of physics are not constraints, but variations, offering a vision of reality as a boundless playground of creativity and structure. This perspective transforms the edge of the universe from a limit into a window of imagination, a calm invitation to explore infinite potential through thought and reflection. In the quiet contemplation of exotic universes, we find perspective. Our observable cosmos, vast and filled with galaxies, becomes part of a grander cosmic narrative, a single instance within a vast ensemble of realities. The edge of the universe, rather than an end, becomes a gentle threshold, a space where the mind can wander freely, imagining worlds with different physics, structures, and possibilities. Here, the infinite nature of reality invites humility, curiosity, and awe, reminding us that existence is far more varied, mysterious, and beautiful than our senses alone can reveal. In the end, contemplating exotic universes beyond the edge of our observable cosmos fosters a quiet serenity. The unseen expanses are not empty or meaningless. They are filled with potential, variety, and wonder, extending reality into realms beyond imagination. Each universe, each region, and each alternative set of physical laws is a testament to the creativity and richness of existence. And as we reflect on these possibilities, we recognize that the universe, and perhaps the multiverse, invites not fear, but contemplation, awe, and a deep, peaceful curiosity about the infinite mysteries that lie beyond our sight. Section 7. Cosmic Horizons and the Limits of Observation. As we venture further beyond the edge of the observable universe, we encounter the profound concept of the cosmic horizon. The universe, in its vastness, is not fully visible to us. Light travels at a finite speed, and the cosmos has existed for a finite amount of time, about 13.8 billion years. This means that the farthest regions we can see are limited by the time light has had to reach us. Beyond this cosmic horizon lies a realm forever hidden, a silent expanse that will never be observed directly, yet continues to exist, evolving in its own quiet, majestic way. The cosmic horizon is not a physical wall or barrier. It is a limit of perception. Imagine standing on a beach and looking out at the ocean. The farthest point you can see is defined by the curvature of the earth and the height of your eyes. Similarly, the observable universe is bounded by the distance light has traveled since the Big Bang. Beyond this limit, galaxies, stars, and possibly entire universes exist, but their light has not yet reached us, and due to the accelerating expansion of space, some regions may never be seen at all. In this sense, the edge of the universe is not a boundary of existence, but a horizon of awareness. The expanding universe introduces another subtlety. Space itself is stretching, and this expansion is accelerating due to dark energy. As a result, some galaxies that are currently visible will eventually move beyond our cosmic horizon, receding faster than light can reach us. They will remain real, yet forever beyond observation, like distant echoes of reality. The universe beyond our sight is therefore a landscape of unreachable wonders, stretching endlessly, shaped by forces invisible to our perception, but obeying the same fundamental principles that govern our local cosmos. The cosmic horizon also raises intriguing questions about the nature of reality and observation. In physics, what can be observed often defines what exists in practical terms. Yet beyond the horizon, there may be phenomena that are real, consistent, and dynamic, yet inaccessible. Galaxies may collide, stars may ignite and die, and new cosmic structures may emerge, all unfolding silently in regions beyond our reach. These hidden regions remind us that reality is not limited to what we can detect. It is far richer, subtler, and more intricate than our perception allows. The philosophical implications are profound. If the universe continues indefinitely beyond our horizon, then everything we see is only a fraction of reality. The cosmos is far grander than our most distant observations, and our understanding is necessarily provisional. This perspective encourages humility, reminding us that the observable universe, with its billions of galaxies and trillions of stars, is just one patch in an infinite tapestry. Beyond the edge lies a quiet expanse that will never be known directly, yet exists as part of the grand cosmic story. Cosmic horizons also inspire meditative reflection on time, distance, and perspective. The light from the farthest galaxies we observe left them billions of years ago. We see these galaxies as they were, not as they are now. Beyond the horizon, events are unfolding in real time, entirely detached from our awareness. The edge of the observable universe is, in a sense, a temporal and spatial frontier, where time and distance interact in ways that defy our everyday intuition. The distant cosmos is alive with history, yet invisible, a silent reminder of the vastness and complexity of reality. Interestingly, the cosmic horizon may not be uniform. Fluctuations in density, gravitational waves, or variations in dark energy could create subtle differences in the expansion of space. These variations might produce regions of the universe that are fundamentally different from our local patch, with unique structures, phenomena, or even variations in fundamental constants. Although we cannot observe these regions, imagining them allows us to expand our understanding of what might exist and to appreciate the boundless diversity of reality beyond perception. Even the concept of infinity becomes tangible when considering cosmic horizons. Beyond our observational limit, space could stretch endlessly, containing countless galaxies, clusters, and superclusters, or even entirely new universes. Each region beyond the horizon is a silent testament to the unending creativity of the cosmos, a reminder that reality is far larger than the mind can fully comprehend. The edge of what we can see is not an end, but a beginning of imagination, a quiet threshold inviting reflection and wonder. Contemplating these hidden regions fosters a deep sense of cosmic serenity. There is no urgency, no need to reach the edge. Instead, we can relax in the awareness that the universe is infinitely vast, with structures, processes, and possibilities extending silently beyond our perception. Galaxies will form, stars will live and die, and entire cosmic cycles will unfold, all beyond the reach of our observation, yet following the same elegant laws of physics that govern our familiar universe. The horizon is a gentle boundary, not a limit of existence, and its hidden wonders encourage calm reflection rather than anxiety or fear. In the quiet of contemplation, one can imagine drifting toward the cosmic horizon in thought, feeling the immense scale and the profound beauty of reality. Beyond the edge lies a universe both familiar in its physical laws and alien in its unobservability, a vast domain of stars, galaxies, and phenomena that exist independently of our gaze. This realization nurtures both humility and awe. We are part of a universe that is infinitely more complex, more expansive, and more mysterious than our limited perception allows. Ultimately, cosmic horizons remind us that the universe is not confined to the bounds of observation. The observable universe is merely a fraction of reality, and beyond the edge stretches a limitless expanse of possibilities, from familiar galaxies to exotic regions shaped by alternate physics, quantum fluctuations, and unseen forces. By embracing this idea, we cultivate a calm understanding that existence is grander than perception, and that the cosmos, in all its vastness, invites awe, reflection, and deep serenity. Section 8. Dark Matter, Dark Energy, and Hidden Cosmic Forces. As we explore what lies beyond the edge of the observable universe, we encounter forces that are both mysterious and pervasive. Dark matter and dark energy. These invisible components make up the majority of the cosmos. Ordinary matter, the stars, planets, gas, and dust that we can see, accounts for only about 5% of the universe. Dark matter constitutes roughly 27%, while dark energy dominates at 68%. Beyond our observational horizon, these unseen forces likely continue to shape space and time in subtle, profound ways, quietly orchestrating the behavior of galaxies, the expansion of space, and the evolution of hidden cosmic regions. Dark matter is a form of matter that does not emit, absorb, or reflect light. Its presence is inferred through gravitational effects on visible objects, such as galaxies and clusters of galaxies. Beyond the edge of the observable universe, dark matter may form vast, invisible scaffolding upon which entire unseen galaxies rest. These regions, while dark to telescopes, are rich in gravitational influence, silently guiding the motion of matter, shaping cosmic filaments, and influencing the formation of structures across scales that will forever remain beyond human observation. In essence, dark matter is the quiet architect of the hidden universe, giving form to what cannot be seen. Even more enigmatic is dark energy, the mysterious force driving the accelerated expansion of the universe. While ordinary matter and dark matter pull gravitationally, dark energy pushes outward, stretching space itself. In regions beyond our cosmic horizon, dark energy may dominate completely, accelerating expansion to such a degree that galaxies recede faster than light can reach us. These areas, though inaccessible, are dynamic and active, filled with an invisible energy that shapes the growth of the universe in ways both elegant and subtle. The edge of the observable universe is thus not a still frontier. It is a boundary of expansion, where hidden cosmic forces silently sculpt reality. The interplay of dark matter and dark energy beyond the observable universe invites us to imagine cosmic landscapes, invisible yet real. Galaxies may cluster along hidden filaments. Vast voids may stretch across space like silent oceans. And yet all of it unfolds quietly, beyond the reach of light or observation. The universe beyond the horizon is not empty. It is a vast, structured, and dynamic arena, shaped by forces we are only beginning to understand. Contemplating this hidden expanse can be profoundly calming, reminding us that much of reality exists independently of our perception, quietly following cosmic laws. Interestingly, dark matter may have properties that differ subtly in regions beyond our horizon. Some theorists suggest the existence of exotic dark matter with unusual interactions or different densities in distant cosmic areas. In these regions, unseen galaxies may form in unexpected configurations, creating structures entirely alien to our experience. Similarly, dark energy may vary across the unobservable universe, producing pockets of faster or slower expansion, subtly influencing the geometry of space. The cosmos in these hidden realms is both familiar in its order and mysterious in its variation, a balance of predictability and surprise. The study of dark matter and dark energy also sheds light on the long-term fate of the universe. Beyond our observable bubble, expansion continues, and these forces will determine whether distant regions eventually drift into isolation, forming separate cosmic islands, or whether interactions, however subtle, persist across unimaginable distances. Some theoretical models even suggest that dark energy could trigger phenomena such as the Big Rip, tearing apart matter at a distant future. While these events may unfold far beyond human timescales and beyond our observational horizon, they highlight the profound influence of hidden forces on the structure and destiny of the universe. Meditating on these invisible components fosters a sense of cosmic serenity. Dark matter and dark energy operate silently, shaping reality without spectacle, yet with immense influence. Beyond the edge of what we can see, they weave an unseen tapestry, structuring galaxies, guiding cosmic expansion, and orchestrating phenomena that will forever remain hidden. The cosmos is not chaotic, but subtly ordered, and even in its most mysterious regions, harmony persists. This perspective encourages calm reflection, emphasizing that the universe's beauty and coherence extend far beyond perception. These hidden forces also inspire imagination about what might lie in completely unobservable regions. Could there be massive structures of dark matter, shaped like webs or vast halos, around galaxies we will never see? Might dark energy interact with these structures in ways that produce phenomena entirely alien to our universe? The possibilities are boundless. Beyond the cosmic horizon, the universe is an invisible symphony, playing patterns of energy and gravity that are beyond observation but fully real. Contemplating these unseen dynamics allows us to appreciate the cosmos's subtlety and grandeur. Philosophically, the hidden influence of dark matter and dark energy underscores the limits of human perception. Our experience of the universe is based largely on light, particles, and forces we can detect. Yet the majority of reality exists beyond these senses, unfolding silently in regions we cannot explore. This quiet reminder encourages humility and reflection. The cosmos is far larger, stranger, and more elegant than the fraction we can observe. The edge of the observable universe is not a barrier, but a threshold into hidden layers of cosmic reality. Finally, dark matter and dark energy highlight the continuity between the observable and the hidden universe. Even as light fades at the horizon, these forces continue to operate, connecting the seen and unseen, the known and unknown. Galaxies, clusters, and filaments are guided by invisible hands, creating structure and coherence that extend infinitely. Beyond the edge, the universe is not empty or chaotic. It is a vast, silent, and harmonious realm where hidden forces quietly shape reality, inviting reflection, wonder, and a serene awareness of the infinite. In the end, contemplating dark matter and dark energy beyond the observable universe offers a sense of calm awe. The hidden cosmos is a vast, dynamic, and intricately organized expanse, extending infinitely and shaped by forces we may never fully understand. Beyond the edge, reality continues in silence and beauty, a universe of infinite subtlety and wonder, reminding us that even in unseen regions, the cosmos is profoundly alive and elegantly structured. Section 9. Cosmic radiation, gravitational waves, and hidden signals. Beyond the edge of the observable universe lies a realm that is invisible to ordinary sight, yet rich with subtle signals that carry the story of distant space and time. Among the most intriguing of these signals are cosmic radiation and gravitational waves, silent messengers that traverse the universe, connecting the observable with the hidden, whispering secrets from realms we may never directly see. These phenomena remind us that the universe is not limited to what we perceive with light and telescopes. It is alive with imperceptible activity, quietly conveying information across unimaginable distances. One of the most important sources of cosmic information is the cosmic microwave background, CMB, the afterglow of the Big Bang. This faint radiation fills space uniformly, providing a snapshot of the universe when it was only 380,000 years old. Beyond our observable horizon, similar radiation persists, carrying subtle imprints of the universe's earliest structures. Tiny fluctuations in the CMB reveal the density variations that would eventually give rise to galaxies, clusters, and cosmic filaments. In this sense, cosmic radiation is like a fossil record of the hidden cosmos, offering indirect insight into regions we cannot see, yet which exist and evolve beyond the edge of perception. Equally fascinating are gravitational waves, ripples in the fabric of space-time, first predicted by Einstein and recently observed from colliding black holes and neutron stars. Unlike light, gravitational waves are not hindered by matter or cosmic expansion. They traverse space unhindered, carrying information from the most distant and energetic events. Beyond the observable universe, gravitational waves could emanate from collisions of massive black holes, the formation of primordial structures, or even violent processes in exotic universes with alternate physical laws. Though we may never detect waves from the most distant reaches, imagining them evokes a universe alive with motion and energy, a hidden symphony stretching across unseen cosmic expanses. Cosmic radiation and gravitational waves highlight the interconnectedness of the observable and unobservable. Even if light from distant galaxies cannot reach us due to the accelerating expansion of space, these subtle signals may still traverse vast regions, conveying traces of the hidden universe. They act as gentle bridges across cosmic distances, offering a sense of continuity and coherence in regions forever beyond direct observation. In this way, the universe beyond the edge is not isolated. It communicates, however faintly, through the persistent whispers of fundamental forces. Beyond our horizon, these signals may reveal phenomena entirely unfamiliar to human experience. Variations in radiation could hint at regions of space with different densities, unique cosmic structures, or even alternate forms of matter. Gravitational waves may propagate from events beyond comprehension, like collisions of hypothetical supermassive black holes in exotic universes, or fluctuations in dark matter and dark energy fields. Each subtle ripple or photon carries a story, a faint trace of hidden realities, showing that existence continues in full complexity, even in realms we cannot access. There is also the poetic serenity in contemplating these signals. They travel silently, unobserved by any eye, yet faithfully trace the unfolding of cosmic events. Like distant ocean waves, felt but not seen, or the faint echo of a bird across a misty valley, cosmic radiation and gravitational waves remind us that the universe exists beyond perception. The unseen regions are vibrant and dynamic, yet their activity is calm and orderly, governed by the same elegant laws that shape our local universe. This subtle activity inspires reflection, emphasizing that beauty and coherence extend into the hidden cosmos. Gravitational waves also allow us to imagine the hidden dynamics of the universe. Beyond our horizon, massive cosmic collisions may occur in complete isolation, shaping the structure of space-time in ways undetectable to us. Entire regions may be sculpted by the gentle interplay of invisible forces, where dark matter halos twist silently around galaxies, and dark energy subtly stretches the fabric of space. These hidden phenomena unfold in a quiet, majestic rhythm, a cosmic ballet that is entirely independent of human observation, yet fully real. Cosmic radiation and gravitational waves also illustrate the limits of knowledge and perception. We are bound by the speed of light, by the age of the universe, and by the expansion of space. Yet the universe does not wait for observation. Beyond our cosmic horizon, reality evolves continuously, carrying on in ways we cannot perceive, but whose existence is assured. These signals are a reminder that the cosmos is infinitely larger and more intricate than our measurements can capture. And that serenity comes from appreciating this grandeur without the need to fully grasp it. Contemplating these hidden signals evokes both awe and tranquility. The universe beyond the observable edge is not empty. It is full of motion, energy, and structure. Gravitational waves ripple through space-time. Radiation carries the memory of primordial events, and unseen galaxies continue to form, collide, and evolve. This quiet dynamism inspires a calm awareness that existence is vast, ongoing, and beautifully ordered, even in regions forever beyond our gaze. Finally, the hidden universe, traced through subtle signals, encourages a reflective mindset. We realize that our observable slice of reality, though immense, is only a fraction of the full cosmos. Beyond the edge, countless processes unfold silently, governed by the same principles, yet inaccessible to direct perception. Cosmic radiation and gravitational waves remind us that the universe is profoundly interconnected, infinitely rich, and serene in its hidden activity. The edge of observation is not a limit, but a gentle invitation to wonder, imagination, and deep contemplation. In the quiet of thought, we can imagine drifting along these invisible waves, feeling the subtle rhythms of the hidden universe. Beyond the observable horizon, galaxies continue to spin. Black holes collide in distant symphonies, and space-time itself stretches and warps in perfect harmony. Though unseen, this activity is real, constant, and calming, a silent testament to the infinite mystery and elegance of existence. Section 10. Quantum fluctuations and the probabilistic cosmos. Beyond the edge of the observable universe, where light cannot reach us and galaxies remain forever hidden, reality may be shaped by forces far subtler than gravity or electromagnetic radiation. Quantum fluctuations, the tiny, random variations in energy that occur even in a vacuum, could play a profound role in creating and influencing these distant realms. In the unseen stretches of space, these fluctuations are not just mathematical curiosities. They may give rise to stars, galaxies, and even entire universes, highlighting the probabilistic nature of existence beyond perception. At the heart of quantum mechanics is the principle that energy and matter are not entirely deterministic. Even in a perfect vacuum, temporary fluctuations produce particle-antiparticle pairs that appear and vanish in the blink of an eye. In regions beyond our horizon, these minute events could accumulate over cosmic scales to create structures unimaginable from our local perspective. Quantum fluctuations may seed galaxies, trigger inflationary bubbles, or even spark entire universes with alternate physical laws. The unseen cosmos is therefore not static. It is alive with possibility, a probabilistic landscape of endless creation. Inflationary cosmology suggests that the early universe underwent rapid expansion. Stretching quantum fluctuations to macroscopic scales. This means that regions beyond our observable universe could be shaped by tiny variations that, over billions of years, produced entire cosmic structures. Some of these regions might resemble our universe, with galaxies, stars, and planets, while others might follow entirely different patterns, where the constants of physics produce alien and exotic realities. Quantum uncertainty ensures that every unseen region is a unique experiment in cosmic creation, a testament to the endless variety of existence. The probabilistic nature of the universe also opens the door to ideas like the multiverse, where every possible variation of physical laws and initial conditions exists somewhere. Beyond our horizon, there may be countless domains where gravity is stronger or weaker, where time flows differently, or where entirely new particles and forces dominate. In these regions, quantum fluctuations act as the ultimate artists, crafting reality with an invisible hand, generating worlds and structures that are both coherent and surprising. Even without observation, these possibilities are real, quietly unfolding according to the probabilistic rules of quantum mechanics. Quantum fluctuations also suggest that time itself may be more flexible beyond the edge of the observable universe. If each distant region is shaped by its own initial conditions and random variations, the flow of events may be subtly different from our own local experience. Stars may form in unique sequences, black holes may merge in unexpected patterns, and cosmic expansion may vary in ways that are impossible to detect. This paints a vision of the hidden universe as a dynamic, ever-evolving tapestry, where probability replaces certainty and randomness is a creative force rather than disorder. The implications of a probabilistic cosmos extend to our understanding of matter and energy. Regions beyond the observable horizon might contain unusual distributions of dark matter or dark energy, formed from the accumulation of quantum fluctuations over unimaginable scales. Some areas might even host exotic phenomena that are forbidden or unlikely in our local universe, such as massive vacuum bubbles, regions dominated by strange forms of energy, or the emergence of entirely new physical constants. In this sense, the unseen universe is a laboratory of endless possibility, where the fundamental principles of reality are continuously explored through variation and chance. Philosophically, the presence of quantum fluctuations beyond the observable universe encourages a calm, contemplative perspective. It reminds us that the cosmos is not entirely deterministic, that reality is not fully constrained by observation, and that creation is ongoing, even in regions we cannot perceive. The universe is vast and probabilistic, yet inherently beautiful, organized by subtle rules and patterns that allow order to emerge from apparent randomness. Quiet reflection on these unseen processes can inspire awe and serenity, a sense of being part of something greater and endlessly creative. The probabilistic nature of the hidden cosmos also emphasizes the interconnectedness of all existence. Even though distant regions are beyond light's reach, quantum fluctuations and the fundamental laws of physics continue to shape their evolution in ways analogous to our own universe. The unseen cosmos is therefore not a disconnected void. It is an extension of the same underlying principles that govern reality here. A vast and silent network of creation, each part shaped by chance and law alike. Imagining these regions beyond the horizon invites a sense of calm wonder. One can picture the birth of galaxies from tiny quantum ripples, stars igniting in distant, hidden corners, and cosmic structures forming through a combination of randomness and subtle order. This vision portrays a universe that is both unpredictable and harmonious, a place where chance events generate beauty on the largest scales, and where hidden regions continue to unfold independently of human observation. In the end, quantum fluctuations beyond the observable universe provide a gentle, meditative lesson. Reality is vast, creative, and probabilistic. The edge of observation is not an end, but a threshold to a cosmos shaped by infinite possibilities, where the delicate interplay of chance and law produces structures and phenomena that we can imagine but never fully see. Beyond the horizon, the universe is quietly alive, a symphony of probability, elegance, and eternal mystery, reminding us that existence is richer and more subtle than perception alone can capture. Section 11. Alternate timelines and the philosophy of cosmic infinity. As we consider regions beyond the edge of the observable universe, we enter a domain not only of hidden galaxies and unseen stars, but also of boundless possibilities in time and causality. Quantum mechanics and cosmological models suggest that beyond what we can observe, reality may branch into multiple timelines, each unfolding independently, each shaped by its own initial conditions and probabilistic events. These distant realms, the concept of a single linear history, gives way to a cosmic multiplicity, a tapestry of alternate outcomes that coexist beyond perception. Alternate timelines arise naturally from quantum uncertainty. In the universe we can observe, every particle follows probabilistic rules, and minor variations can produce dramatically different outcomes. Extrapolate this principle to regions beyond our cosmic horizon, and we can imagine an infinite set of timelines, each with its own galaxies, stars, and planets, evolving in ways that may be wildly different from our local reality. In one hidden region, a galaxy may form entirely from exotic matter. In another, stars may ignite and collapse in unusual sequences. These alternate timelines exist silently, unseen, yet fully real in the framework of cosmic law. The concept of cosmic infinity further deepens this vision. Beyond the observable universe, space may extend without bound, creating an endless canvas for alternate realities. Each infinitesimal patch of space may host conditions slightly different from the next, producing variations that accumulate over vast scales. Some regions may mirror our own universe almost exactly, while others may diverge completely, where the constants of physics differ and entirely new forms of matter or energy exist. The hidden universe is therefore not only vast, but infinitely diverse, a profound reminder of the richness of existence beyond what we can observe. These ideas have profound philosophical implications. They challenge the notion that reality is limited to what can be seen or measured. Beyond the edge, existence continues in full complexity, guided by law, yet shaped by chance. Alternate timelines, quantum fluctuations, and cosmic variance suggest that observation is never necessary for reality to unfold. Regions beyond our perception are alive with processes, structures, and histories that will never be known directly, but remain fully part of the cosmic story. This perspective encourages humility, reflection, and a deep sense of calm wonder. Cosmic variance, the natural differences that arise between regions of the universe, amplifies this sense of hidden richness. Even in areas governed by the same laws, slight differences in initial conditions can produce strikingly distinct structures. Galaxies may be denser or more diffuse. Star clusters may form in unexpected patterns, and the distribution of dark matter may create unseen cosmic landscapes. Beyond the horizon, these variations are multiplied across unimaginable scales, creating a silent symphony of diversity that underscores the complexity and elegance of the universe. Alternate timelines also provoke reflections on time itself. Beyond the observable edge, the flow of events may be subtly asynchronous relative to our own local timeline. Cosmic expansion, local variations in gravitational fields, and quantum uncertainty could all influence the pacing of events in distant regions. Stars may live and die according to rhythms that differ from our local experience, and entire cosmic structures may evolve in ways unrecognizable to us. This reinforces the notion that time is not absolute, but deeply relational, and that the universe beyond observation is a dynamic arena where countless histories unfold independently. The philosophical contemplation of these hidden realities is both humbling and calming. The universe beyond the horizon is not chaotic or hostile. It is infinitely patient, endlessly creative, and profoundly ordered, even when governed by randomness and variation. The unseen cosmos demonstrates that existence is far richer than our immediate perception, and that beauty and coherence persist even in regions forever inaccessible. Reflecting on this can foster serenity, encouraging us to release the need for control or complete understanding, and to appreciate the quiet magnificence of existence. Beyond the horizon, the interplay of alternate timelines, quantum events, and cosmic variance creates a landscape of infinite imagination. We can picture universes where galaxies collide in extraordinary formations, where stars burn with unusual intensity, and where hidden worlds evolve under laws subtly different from our own. These mental images remind us that the universe is not a single narrative, but a multiverse of possibility, a profound expanse that exists whether or not it is observed. Each hidden timeline is a testament to the limitless creativity of the cosmos. Contemplating alternate timelines also evokes a sense of connection to the cosmos. Even though these regions are inaccessible, the principles that govern them, the laws of physics, quantum probabilities, and cosmic evolution, are continuous with those we experience locally. The hidden universe is therefore a reflection of the same underlying order, a mirror of natural laws extended to infinity. This continuity reinforces the calm realization that the cosmos, in all its vastness, is coherent, harmonious, and deeply elegant. Finally, considering what lies beyond the observable universe encourages a reflective, meditative approach to existence. The idea that countless alternate realities unfold silently, shaped by chance and law alike, allows us to embrace uncertainty without fear, to appreciate the beauty of what is hidden, and to recognize the infinite richness of reality. The edge of the observable universe is not a barrier, but a threshold, a reminder that even in regions we cannot see, life, motion, and cosmic creativity continue in harmony, infinitely diverse and eternally serene. In the quiet of contemplation, one can imagine drifting along these alternate timelines, sensing the multiplicity of outcomes, the silent birth of galaxies, and the infinite variety of cosmic evolution. Beyond the edge of perception, the universe exists as an eternal symphony of possibility, a grand unseen reality that invites awe, reflection, and a deep, peaceful understanding of the infinite nature of existence. Section 12, Cosmic Repetition and Mirror Universes. As we journey further beyond the edge of the observable universe, the concept of cosmic repetition begins to emerge. In an infinite or near infinite cosmos, the same arrangements of matter and energy may occur countless times, not as exact copies, but as echoes of possibility. Stars may align in patterns reminiscent of those we know. Galaxies may take on familiar shapes, and even planetary systems may mirror our own, all while remaining completely disconnected from our local horizon. These mirror-like structures are not illusions. They are real, unfolding quietly in regions we cannot observe, reminding us of the subtle patterns that pervade the cosmos. Cosmic repetition is tied to both statistical probability and the scale of infinity. Given enough space and enough variation in initial conditions, the universe's fundamental laws allow for configurations to recur. Beyond the observable horizon, the probability that some regions resemble our own or follow similar evolutionary paths grows. This does not imply exact duplication. Quantum randomness ensures subtle differences, but it highlights a profound principle. Even in regions we cannot access, patterns emerge, coherence persists, and structure is sustained. The hidden cosmos is therefore not chaotic. It is remarkably orderly, even in its vast anonymity. Mirror universes, a concept closely related to cosmic repetition, stretch this idea further. In some models, every particle and quantum event may exist in complementary arrangements somewhere far beyond observation. Entire regions of space may reflect our own universe's structure, yet with variations subtle or dramatic. Stars may burn brighter, galaxies may rotate differently, and the flow of cosmic events may diverge in unpredictable ways. These mirror universes highlight a profound symmetry and balance within the cosmos, where repetition and diversity coexist harmoniously. The philosophical implications of cosmic repetition are striking. They suggest that reality is not singular, but manifold, that the universe's richness extends far beyond what can be directly observed. Beyond the horizon, patterns may recur endlessly, and possibilities we consider rare or improbable may actually occur somewhere. This realization encourages a calm, reflective mindset. The universe is both vast and generous, offering countless iterations of structure, life, and energy, even in realms that will never be accessible to us. Infinity, in this sense, is a source of quiet wonder rather than disorientation. Mirror universes and cosmic repetition also influence the way we imagine time. Beyond the observable universe, timelines may echo familiar events while diverging in subtle ways, producing alternative histories of cosmic evolution. Stars may ignite in sequences that parallel our own, yet with differences in scale or intensity. Galaxies may form along similar filaments, yet be separated by immense voids. Each repetition is a variation on a theme, a cosmic melody played with infinite subtlety and nuance. In contemplating these echoes, we gain a sense of serene continuity, realizing that the universe beyond observation is both dynamic and elegantly structured. Hidden repetitions are not confined to matter alone. The interplay of dark matter, dark energy, and gravitational forces may also exhibit recurring patterns. Cosmic filaments and voids may mirror the structures we see locally, creating a vast, invisible network of organization. These unseen structures highlight a hidden geometry of space, extending indefinitely beyond the horizon, governed by familiar physical laws, yet uniquely shaped by local variations. In essence, even the most distant and inaccessible regions of the universe participate in a vast, coherent design. Considering cosmic repetition also leads to reflections on the nature of probability and possibility. In an infinite universe, every possible configuration, within the constraints of physical law, must exist somewhere. Beyond the observable edge, there may be galaxies where entirely new forms of matter dominate, stars that behave according to unusual physical principles, and planetary systems with conditions unimaginable in our region. These possibilities are not hypothetical. They are likely realities somewhere in the hidden expanse, silently unfolding according to the universe's probabilistic logic. Mirror universes and cosmic repetition encourage a sense of cosmic humility and calm reflection. They remind us that our local experience, while vast and complex, is only a tiny fraction of reality. Beyond our sight, entire realms exist, echoing familiar patterns while introducing endless variation. Observing these possibilities from the perspective of imagination allows us to appreciate the immense richness and continuity of existence, cultivating a tranquil awareness of our place in a universe that is infinitely diverse yet subtly ordered. Philosophically, these concepts intersect with ideas of interconnectedness and universality. Every distant, repeated pattern is a testament to the consistency of natural law, even across regions we cannot perceive. The universe is coherent and harmonious, with repetition and symmetry emerging spontaneously through fundamental principles. By contemplating these hidden echoes, we gain a sense of connection to the broader cosmos, recognizing that our local environment is part of a far larger, infinitely patterned reality. Finally, cosmic repetition and mirror universes inspire calm wonder. The universe beyond the observable edge is not empty. It is full of hidden structure, repeated patterns, and subtle echoes of possibilities. Stars, galaxies, and cosmic filaments continue to form, collide, and evolve in ways that may remind us of our own region, yet remain profoundly unique. These patterns unfold silently, invisible to human eyes, yet fully real. They offer a vision of infinity that is both peaceful and inspiring, a reminder that the cosmos is vast, elegant, and continuously creative, extending forever beyond the limits of observation. Section 13, Beyond Observation: Infinity, Wonder, and the Unknown. As we reach the final contemplation of what lies beyond the edge of the observable universe, it is natural to step back and consider the vastness and serenity of the hidden cosmos. Every section we have explored, from dark matter and dark energy to quantum fluctuations, gravitational waves, alternate timelines, and cosmic repetition, has revealed layers of reality that exist independently of human perception. Beyond the horizon, there is no abrupt end, no barrier, but rather a continuous expanse of space, time, and possibility that stretches into infinity. Here, the cosmos is both silent and dynamic, invisible yet alive with the ongoing processes of creation and evolution. In these hidden realms, the universe continues to function according to its fundamental laws. Galaxies form, stars ignite, black holes collide, and dark energy continues to stretch space itself. Quantum fluctuations birth new structures, and probability dictates the endless variation of possible outcomes. Even without observation, every event unfolds with coherence and elegance. The regions beyond our perception are quietly majestic, an eternal testament to the order and beauty inherent in existence. One of the most profound aspects of the hidden universe is the sheer scale of possibility. Infinite space allows for an infinite number of configurations, galaxies resembling our own, stars with unusual life cycles, and perhaps even universes with physical laws subtly or dramatically different from ours. In this framework, every conceivable arrangement of matter and energy occurs somewhere. Beyond the observable edge, the universe becomes a canvas for infinite creativity, an ongoing symphony of existence where both order and variation coexist in perfect balance. Contemplating this hidden expanse evokes a sense of calm humility. Our observable universe, though immense, represents only a fraction of reality. Beyond the edge, processes continue, unobserved yet fully real, reminding us that the cosmos does not rely on awareness to exist. This encourages a serene perspective. Life, motion, and energy extend far beyond the scope of human experience, and the universe is far more generous and intricate than we might imagine. The philosophical resonance of this hidden cosmos is profound. By understanding that alternate timelines, mirror universes, and infinite repetition may exist, we begin to see reality as both interconnected and boundless. Patterns emerge across the unobservable expanse, echoing familiar structures, yet introducing endless variation. Laws of physics operate consistently, creating order even in regions forever beyond our reach. The universe is simultaneously comprehensible in principle and mysterious in practice, a vast stage of unseen activity that invites reflection, imagination, and wonder. Gravitational waves, cosmic radiation, dark matter, and dark energy continue to shape the distant cosmos, and even though we may never measure these signals directly from the furthest reaches, their existence is certain. They are a reminder that existence does not require observation, that the universe is real and vibrant, regardless of perception. Beyond the horizon, events unfold continuously, governed by law, probability, and chance, creating a hidden symphony of cosmic activity that is quietly mesmerizing. Ultimately, the edge of the observable universe is not a wall, but a threshold to infinite possibilities. Beyond it lies a cosmos that is alive in ways we cannot see, yet fully structured, elegant, and coherent. Here, quantum fluctuations ripple into cosmic structures. Alternate timelines coexist in parallel. Mirror universes echo familiar patterns, and dark energy stretches space to unimaginable distances. This is a universe where everything that can exist does exist somewhere, and where reality continues infinitely in space and time. Reflecting on these hidden regions offers a sense of peaceful awe. The universe is far larger than perception alone can capture. Beyond the horizon, life, energy, and cosmic evolution continue silently, elegantly, and eternally. There is a profound serenity in this recognition. The hidden cosmos is a realm of continuous creation, infinite diversity, and subtle beauty, extending forever into the unknown. In closing, the universe beyond the edge of observation invites us to embrace wonder and humility simultaneously. We are reminded that human perception is limited, yet the cosmos is vast, coherent, and infinitely richer than we can imagine. The hidden universe operates with calm precision, a silent testament to the eternal elegance of existence. And perhaps the most intriguing thought of all is this: somewhere, infinitely far beyond what we can see, entire regions of reality unfold in patterns both familiar and alien, existing fully yet silently. As if the cosmos itself were a hidden symphony we are only beginning to imagine. This sentence encapsulates the essence of the journey. The universe is alive, vast, and infinitely creative, extending beyond the reach of light, time, and observation, yet wholly real and profoundly beautiful.